Hi. So what we're going to do is look at what is called the locus of a point. And what the locus is, plural being loci, is the set of points that describes all the points within a given condition. Okay? So it's something we can do with complex numbers to describe it on the arcane diagram. So what I'll do is compare the following. We're going to look at the modulus of z equaling 3, and then the modulus of z being less than or equal to 3, and you'll see the difference of what I mean about the description, as that is the condition that I've put on the complex number, given such that z equals x plus iy. So the steps we're going to do is sub nz for x plus iy, calculate the modulus. Now if you remember that from looking at the arcane diagram, that's actually just calculating Pythagoras, but we'll look at it in detail. And we can interpret the equation. And there's quite often the same sort of equations keep turning up again and again. But let's look at these two examples. So we're going to get the modulus of x plus iy equals 3. Now to find the modulus, we're actually going to ignore the I. Okay, so that might be a bit confusing at first. So what we're going to get is the square root of the x component plus the y component is equal to 3. I'm ignoring the I because we're finding the absolute value of it. And then we can exchange this into an equation we recognise by taking the square root across and making it into 3 squared, which is 9. And then you can see that this is actually an equation of a circle with a centre of 0, 0 and a radius equal to 3. So if I was to sketch that, we're going to have 3, 3, 3, 3, and a circle like that. Right, well, that's obviously a terrible circle, but you hopefully get the point. And what it is because it is z equal to x plus iy, the locus is the circumference of the circle. That's the only points that I care about. That is the description because it is equal to 3. That is the point 0, 0. Every point on that is a distance of 3 away from the centre point. Whereas if we were to look at less than 3, we're going to have the exact same effect. We're going to get x plus iy, but less than or equal to 3, which is going to give us x squared plus y squared square rooted less than or equal to 3, which is going to give us x squared plus y squared less than or equal to 9, which is the exact same equation of a circle. Centre 0, 0. Radius equal to 3. So it's going to look very similar, but it's everything that is less than or equal to 3. So it's not just the points on the circumference of the circle, it is actually everything in between, everything in it. Because all of these points are a description based on that. The first one was just the circumference because it was at what point is that 3 units away from that point, whereas this is what point is 3 units, what are the points 3 units away and everything closer. Okay, so we'll do another few. So, given that z equals x plus iy, find the equation of the locus and then draw the locus on an arcane diagram for z plus 1 plus 2i equals 3. Okay, so what we need to do is substitute z for x plus iy. So we're going to get x plus iy plus 1 plus 2i equals 3. What I'm going to do is combine the real and imaginary parts. So we've got x plus 1 plus y, x plus 1 plus I y plus 2 equals 3. So we've got the real parts there and the imaginary parts there. The reason I'm doing this is because now I'm going to do the modulus of it, which is the square root of just the components, which is going to be x plus 1 squared plus y plus 2 squared equals 3, ignoring the I. And then we can get x plus 1 squared plus y plus 2 squared equals 9. And you can see what I mean, it's the same functions come up again and again and again, as that is another circle. So it's an equation of a circle with center -1, -2, and radius equal to 3. So then if we have to sketch that, -1, -2, with a radius of 3. So it's going to look something like that. Worst circle ever. And it is equal to 3, so it is only the lines, only the points on the circumference of the circle. If it had been less than 3, it would have been everything within it. If it had been greater than 3, it would have been everything out with it. But it's equal to 3, so it's everything on that line that is a distance of 3 units from that point, -1, -2. Okay, so far we've done 3 circles, if you can call that a circle. What I'm now going to look at is something that doesn't end up as a circle. So I've given the argument of the complex number. Okay, so given that z equals x plus iy, find the equation of the locus and then draw the locus on an argand diagram for arg z equals 2 pi by 3. So the first thing we're going to need to find is the y and x values. So we've got tan to the -1 of y over x equals pi by 3. Normally we'd be doing it in reverse. Therefore, y over x equals tan of pi by 3. And pi by 3 is just, tan of pi by 3 is root 3. So we've got y over x equals root 3. Therefore, y equals root 3x. And that is the equation of a straight line m equal to root 3, and it's going through the origin, y intercept 0, 0. So I can now sketch that. So what it is a line going through the origin with a gradient of root 3 so it is every point on that line from -infinity way back down here to +infinity to be up there. So they generally end up being circles or straight lines, and it's just you need to realize what's happening at the time. Okay? So that is how you sketch the locus of a complex number on a specified condition.